Hi, so good morning again. So I'm preparing this video as the previous video was not captured properly and there was some glitching. This is the another option I have taken. There is some problem with my X window, that's why it was not good. So yeah, so I just tackling the same thing again. So this is the cell designer software that I have shown you in the previous video, and as you can see, it has many elements and the reactions. Each elements will be interacting with other elements through the reaction. Each reaction will be given an ID. Okay, and you can list all of the elements, which is the reactant, which is the product, what's the outcoming, what's the incoming. So based on that you can give values to the elements, how many incoming reactions are there. Based on that you can give +1 like that. Okay, how many outgoing reactions are there. Based on that you can give -1 to that elements, or I can say proteins, substances, something species. Okay, so like that you can give values to that. Once we give +1 -1 kind of value, so before that I just explain what's the better easiest way we were having is to convert it into a simplest alphabetic formats. So each of the names or species are named into A, B, C like that, and each of the reactions are named into B1, V1, V2, V3 like that. Okay, this makes us simple to understand and simple to calculate. Earlier what we were doing, it is the way we were doing earlier. So once we have all this incoming and outgoing data for all the species, so we used to get give value to the elements. So A has 0 according to V1. V1 is one reaction that is not in that means A is not involved in V1 reaction. It's not involved in V2 reaction like that. That means 0 means there is no reaction involved. So as you can observe at the end, it is B1 given -1. That is uh, A is involved in B1 reaction. It's an outgoing reaction. That's why it's given -1. Like that B is involved in B2 reaction. It's given it's an outgoing reaction given -1 value. And we can observe there are some 1 are also there. So that means it's involved in V21 reaction. U is involved in that reaction like that. We used to give values to all the elements. Once we give value, all these details or numerical data is taken in the form of a matrix and put into MATLAB or free math software. Okay, so make them comma separated and row and columns like you can make that and put it into a variable, so it will be displayed like this. So the rows are the reactions and the columns are the species elements. Okay, so this is the way it's been calculated. Once we have this all this data in a variable, we need to perform a single value decomposition for that matrix, for that value. So there is a function svd function. We call that function on that variable, and that will give output three variables that will give as output. That is u will take that as u comma s comma v, put that into okay. So u s v is the output that comes. We just enter. So you can see u variable contains this kind of data, s contains this one, v contains this one. We don't understand anything of it properly, what it is, what is the value. So we are interested in this v variable, so we'll just plot that variable v, and we got some graph. So below are the what I can say x-axis is the elements and y-axis is the values given to that. So as you can observe, this some 10th element has a least value -0.8, and there is another one. So what we observed is the 10th value. So 10th one is j. So yeah, j. So jth value, when we go back to that pathway, we found that there is one element, RAV6 or some element of that pathway that has been noted as one of the target protein based on the wet lab experiments. So, and we also found the same thing when we do this kind of analysis. So there was a coordination, and there was a meaning like this is the proper way we are doing. So we wanted to automate this thing, whatever we are performing, all these things we wanted to automate. So because there will be a lot of as you can see, pathways will not be a smaller one like this. There will be many more pathways, and it will contain numerous hundreds of thousands of elements and reactions. So for all of that we cannot automate, we cannot perform this kind of task manually. And there is a there is a way to add or merge different pathways in this cell software, and merging that also. After merging we need to perform this kind of task. That will be really hectic, and it was not possible also. And even in this pre-med software you can take only about 19 to 20 rows or columns, not more than that. You cannot even enter any more values or rows. It would give you error, it won't take it out. So that was the limitation we had. So for this purpose, and the numerical data will also be huge, so we need one automated. There may be a manual errors will also occur in that case, so we need to avoid that also. So we need to have one automated system to perform this kind of task. So as you can see, this this SVD function will be available for Java. You can integrate that into your codes and make it work. Yeah, this is the research article we have prepared. I will share this one with you people. You can go through that. It has explained what we are doing and what it should be like. We need to prepare a matrix, calculate the SVD, calculate beta or something they mentioned, USP respective latest what I have shown you. So you can just go through that. If you don't understand, you can just call me back, and I'll share this file also. Okay, so this is the way we are planning to build this tool, and it's a small one actually, but has some expected feature. Okay, so this is what I wanted to show you in the previous videos. Okay, anyway, I think it's working good, it's captured good, and thank you again.